So today, guys, we're going to lecture about and work on a program that will use files rather than keyboard input as our input and our output. Yeah, screen's coming in. So if we're using file streams, then reading from a file is as easy as reading from the keyboard, or virtually as easy. Just a little bit more we need to do. So you can pretty much take any program that reads from the keyboard and convert it to read from a file pretty easily. So I'm going to open up Visual Studio and I'm just going to write an itty-bitty little program that reads from a file. Excuse me, that reads from the screen. So go ahead and make a new project. I don't think it's going to need anything but IO stream and maybe string at first, but we'll later have to go in and add something else. So let's write a loop that will read in a series of numbers, and when the user types in a sentinel value of -1, it stops and it will average those values. So cout, enter one or more values, ending with -1 to stop. Except I put the wrong arrows on the cout. There we go. Now I want us to read in at least one value. So I'm going to use a do while loop. Do some stuff while input is not equal to -1. Now we don't have a variable called input yet, so I'm going to have to correct that. I'm going to come up here and define an integer or a float called input. I'm going to set it to something other than -1. Doesn't matter, I can set it to -1 because we're going to read in something first. Okay, so let's read in to the input variable. And if input is greater than 0, let's add that to our sum. Sum plus equals input. Now I haven't defined sum either, so I have to go back up here to my float statement and add another variable. Input is equal to 0, comma, sum is equal to 0. When they finally enter a -1, we're going to print out what the sum was. The sum of all, or the sum of those values is followed by the sum, and followed by ENDL. It's possible this will actually work. Let's give it a shot. Enter one or more values, ending with -1 to stop. 12, 25. We're not seeing any output. We might want to put some output inside that loop, so that we can see that something is happening. And then we type in -1 and it sums them all up, and I'm going to trust that that's correct. I guess I could run it again and take careful note of what values I'm adding. Like 100, 200, 300, and then -1, it should be 600. Okay, so that's working. I want yours to get to the point where that's working as well, because the next thing we're going to do is to make it a little bit trickier when we read from a file. So I'm going to do this in two parts. The first thing I'm going to do is I'm going to store this output in a file. So when it says the sum of these values is such and such, we're going to write that to a file. Is this working for everybody? Anybody getting any syntax errors? Sure. So CIN and COUT are streams. Streams can go to the keyboard and to the screen, but they can also go to files. You can read from a file using a stream, and you can write to a file using the stream. So I'm going to go to the PowerPoints. Using files for data storage. You can use files instead of the keyboard and the monitor for input and output. Why is that important? Well, it allows data to be retained between program runs. It'd be a real drag if every time you wanted to print your resume, you had to type it in all over from scratch if you couldn't save it. Couldn't save your resume to a file, then that'd be pretty pathetic. So that allows your data to be retained from program steps. So generally what you want to do is you open the file and then you do something with it. That something could be you read from it or you write to it or both. And then you close the file. So to get our files to working, we're going to need the Fstream header. And then there are two different types of streams. Well, there's really three that we're going to use. One is known as an IF stream, and one is known as an OF stream. Guess what the I stands for? Input. IF stream stands for input file stream. OF stream stands for output file stream. So since we're going to modify our program to write to a file, we're going to use OF stream. And to define one of these objects, we're going to use OF stream followed by a variable name. They suggest outfile. Outfile is perfectly good for me. Okay, I'm not seeing nice little code samples, so we're just going to roll our own here. Here's a code sample from reading in from a file, but it didn't show how to write to a file. So we're going to have to add our code to do # include fstream. So I'm going to go back into my code up here and # include fstream. Now I need to open my file. Well, I need to declare my variable first. So under that line that says float input equals 0, I'm going to add a line that creates our output stream. OF stream outfile. And then we actually have to open our file. So we're going to call the open method on our outfile variable, outfile.open, and we're going to give it a name. So here, after I do ofstream outfile, I'm going to do outfile.open, and then I pass in a file name inside the parentheses. And I think I'm just going to call it output.txt. No. Let's give it a more creative name than that. Results.txt. Yeah, that's unique. No one had ever used that. Now, I should test to make sure that the file was actually created. And you do that with an if statement. So I can do if not out file, then write out an error message. And when would you have an error? What if you tried to write to a drive letter that didn't exist? You know, like back in the old days you had floppy drives A and B, you know, and then C was your hard drive. Well, if we try to write out to A : on these machines, they don't even have floppy drives. You know, or they have the CD-ROMs or the disc, you know, DVD writers, but nothing at A or B. So if I tried to outfile open A : \results.txt, that wouldn't work. We would get an error. So if not outfile, I need to print an error message. Cout could not open file. Now, if I was really a clever programmer, I would store the output file in a variable name so that I could then print it out real easily. But I didn't do that, and I'm not going to modify the program to support that now. And since that didn't work, I'm just going to bail out. So I'm going to return a value right then and there. If I couldn't open the file, there's no reason to keep going. So I'm bailing out early. So above my do loop, I have these new lines added. Fstream space outfile, outfile.open, followed by the file name. If not outfile, then write out an error message and return. Okay, I'm going to run this, and it's not going to do anything useful because I'm not actually writing anything to the file, but I'm just going to make sure I don't have any syntax errors. All right, I don't. All right, we're going to get to the point where I'm going to be scrolling up and down a lot, and I don't like making it do that, so I'm going to try to condense this code to as few lines as possible. Okay, where it says CIN __ input, let's write our output out to the other file. So I'm going to say out file __, the arrows are pointing to the out file, and I'm going to put the word read, as in read, not the color, input, followed by the end of line. So we just read something from the keyboard input, and as soon as we do, we're going to write it to the out file. And I want to see if that works. So I'm going to run it. I'm going to type in like 3 values, 100, 200, 300, and then -1. And it says the sum of these values is 600. Good. Now, I should have been writing out to this file the entire time. So I'm going to look for that file. I'm just going to go to the search menu and type results.txt. There it is. There's our documents, results.txt. I can double click on that, and there is the output that it generated. It read 100, it read 200 because I typed that in, it read 300, and then it read -1. Now that's more like a debug log, huh? It's not actually any useful output. It's not recording the sum or anything in there. So it'd be a good idea to also write the sum out. So down here where we say cout the sum of these values is, just copy that line and send that line as well to the out file. Out file __, the sum of these values is. Now if I search for results.txt again and open it up, it actually has that line of output added to my file. The sum of these values is 600. Now this particular way of opening a file is blowing away the prior contents of the file. which may not be what you want to do. If you want to open it for appending, there's a way you can do that. This is opening for overwriting. Okay, I'm going to zoom out just a little bit. Try to get as much of it on the screen as I can. I know it's hard for y'all in the back of the room to read once I do this, but at least I get more of the code on the screen at the same time. Okay, that's about as much as I can get on there. Okay. Go ahead and run it and then see if you can find your results.txt file. Zero would make a good signal back as well. But what if zero was also a valid value? Like you were entering a series of rainfalls. You know, if you were going to enter a series of rainfalls and then zero, you know, may actually have zero, you would not want your data entry loop to fail out just because you entered a zero. But you might not want to print that red Z minus one. Right. What you would do is you would move this out file read line to be inside this if input is greater than zero. It actually should be if input is greater than or equal to zero. So that's a good change to make. But it's going to require adding a little bit to it. Your change is awfully good. Here we go, just right here. If input is greater than or equal to zero, I'm going to take that, add a brace because I'm adding code there. I'm going to output that to the file, and then I'm going to add that to the sum. So I changed the code a little bit, and I'm sorry to do that in midstream. You don't have to make that change if you already had it working. So does that make sense?
Yep.
Yeah. Okay. Good point.
His Visual Studio decided to not it's not showing his project.
It's not showing it's open. Is it open? No, wrong.
Yeah, sorry.
Put it on.
There used to be a common reason that Adobe software would do that, but I don't remember what it was. I remember to fix it, you just had to go into the views and like change the configuration and then lock it, basically. It's like a bug, like every time you did a certain thing, if it wasn't locking, you do that. Is there a certain name for the, oh, is it called class view? No. What's the name? What is this thing called in Visual Studio? The text editor box.
Yeah. Anyways, yeah, see if you can just go find a file that way. That's very odd. Have you tried quitting Visual Studio and relaunching it?
I tried to open. Yeah. So I'm not sure.
I'm not seeing your newest. Oh, you call it cast, yeah. Okay.
I bet Visual Studio stores your like preferences in a certain folder. If you delete it, it'll start from scratch, like
Yeah.
default. Or sorry, in a certain file, and if you delete the file, it'll start over with still showing things.
We'll have to find a way of resetting it, but at least you can work from it from there out. All right, so working for everybody, or you need help?
This one time when I was 5 and I lived in 2011 kids, I got left home alone for Christmas. said a bunch of booby traps pointing after accidentally stealing a toothbrush. And my mom had red hair and she looked really awesome for her age because it was the 80s. The end. Oh, and Joe Pesci was in there somewhere. Oh yeah, what was the
Okay.
negative 1 versus 0 question?
So the reason we made this little bitty change here, we put the out file arrow line underneath or as part of the code block for the if input greater than or equal to 0 statement, is so that we don't write out that -1. Because we were before, you know, it said read, 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 and, you know, and then it said read -1. Well, I don't want to see that in my output. So I only display that, I only send that to the output if I know that the value we just read is greater than or equal to 0, not if it's a -1. So go into your directory structure, into your documents folder, into your Microsoft Visual Studio directory. Where is that? Visual Studio 2013, projects, find your newest console application, go into the thing that actually has your CPP file, and you should see a file called results.txt. Let's create a new file in the same directory that we will use for input. So now that I'm in the directory called results.txt, I'm going to just right click and do new text file. Out of all this stuff, new text document. There it is. It's called new text document. Change that to input.txt, the name of it, when it creates it. And then double click it and let's put some input into it. Now the numbers can each be on one per line, or you could have a whole bunch of numbers on a single line as long as it's terminated by a -1. So 100, 200, 300, and -1. There we go. That'll be enough. And I'm going to close that and save it. I'm going to modify this program that we've just written to read from that file. I think I'm going to save this intermediate run though. There we go, that intermediate version. Okay. So now we have to create an input file as well as an output file. Things are going to look a little bit nastier here. I'm almost wishing we would start a brand new program at this point. But we no longer need this line that says enter one or more values ending with -1 to stop, because we're reading from a file. We don't need to tell the file that it needs to enter a value ending with -1 to stop. So I'm just going to delete that entirely. That line that says cout, enter one or more values. Underneath the lines of code that check to see if we could open results.txt, we're going to create an input file. So just like we did ofstream space out file, we're going to do ifstream space in file. And in file.open input.txt, or whatever you named your file. If you follow my example, you named it input.txt. And you want to make sure that that file is open. So you do the same if statement. If not in file, cout could not open input file. I think I'm going to make it say input.txt file because we happen to know its name. Rather than hard coding these things, I should give them, you know, variable names, but I didn't. And then let's return an error there. Now the only change we need to make is everywhere that CIN appears, we need to change that to in file because we're reading from the file rather than from the keyboard. I think we only have one place where CIN appears, and that's in our do loop. So in file, arrow, arrow, input. That's the line that I changed right there. was CIN input. It is now in-file error.
You would return negative one on both of those. Is that how it's supposed to be?
That's okay. Yeah, realistically, if we were going to try to make a unique list of error codes, one of them should be -1, one of them should be -2. But we never check the values of our codes, that we're returning, so.
Thank you.
Alrighty, with those changes, it'll run, it won't ask for any user input, and whatever you saved to that input.txt file will be summed. And you can go and open both results.txt to see what you read. Sorry, uno momento. So I'm going to open results.txt. I should still have that folder still open. So there it is. I open it up. It said it read 100, 200, 300. I'm going to change the data of the input.txt file to something else. I'm tired of seeing 100, 200, 300. I'm going to make it say 23, 33, 43, 53, whatever. Just a big series of numbers. There we go. Now when I run it again, it'll sum up those values, and I'm going to check the results.txt file to make sure that it read the new stuff. The sum of those values is 50,000. Cool enough. Open up results.txt, and there they are, 23, 33, 43, and all those other numbers I typed in. Alrighty. Who's getting syntax errors that they need help with? Yours may be a little bit different just because you're using something else other than Notepad.
Getting blank screen then? Me too. Are you getting a blank screen when you run? If you might be dehydrated when you're running. You're missing the line of credit on your insurance statement. You're a really nice guy. Do you know that way, dear? You're like a super patient person.
Yeah, well, I can't see.
Uh,
Yeah, it doesn't run. Yeah, so we don't have to help files.
Hey Nathan.
Nope.
If I bring a bunch of friends to Omniplex one day when you're on lunch break, do you wanna chill? We could eat ice cream out of 3D printed dicks. Like 3 or 4 friends.
Yeah, sure.
Only if you want to, because you said to visit you and I haven't yet. I'm like beginning to feel guilty.
No, don't feel guilty, man.
Like I do want to
Nobody
visit
ever
you.
comes to visit me, that's cool.
I do want to visit you in your prison cell, but I just have had a lot on my plate.
Dude, you're totally cool. Yeah, Saturdays I get an hour long lunch.
Foaming at the mouth with this opportunity.
Yeah?
Yeah,
Why?
because I'm foaming at the mouth. I'm rabid.
Yep, I was gonna say you got rabies.
I did too many things with too many ducks. And possums.
Got any quapes?
What?
Nothing.
Did you say grapes?
Quapes?
Grapes. When I was little, I tried to keep a possum. I thought it was a set of brackets here.
Why not?
It was like
we had a possum get in the meat department, and
So that's like probably a few $1,000s worth of damage just because it was in there.
no, he still sold it. He was gross.
Oh.
Yeah, he was. Yeah.
Man, if somebody found out about that, like you would have lost his whole store.
Yeah. And so I told him to call animal control, and he goes, no. He goes, the possum gloves are in my office. Go put them on. And go, yes. Big leather gloves that went into my elbow, and I did. I had to get it
Dude,
out.
I've caught squirrels and possums. They'll bite right through that crap. Yeah, it hurts.
They'll like climb up their tail trying to get to you.
Yeah.
Yeah, it's not
Yeah,
fun.
well, if squirrels, their tails will fall off. It'll just be like the skin and the fur will come off. It'll be like a bloody boat. So you can't like catch squirrels by their tails. Like possums, they're almost prehensile. So like I imagine you just swing them around so they can't climb on you. Is that what you did?
Kind of, yeah, like up and down, and
Yeah. That's what I'll do with like gophers and rats if they're feisty until they calm down. Like every time they're trying to like until they chill out. Caught gophers and tamed them that way. It takes like 2 seconds to see. Once they stop freaking out, you can like let them sit on your arm. And
that's cute.
gophers are pretty cute once they're chill. They like to take naps and try and burrow into your armpits. That's the true truth. Cloud Atlas. I haven't seen that movie yet, all the way through. Did it suck? It's not a gopher.
It says it's a gopher.
I don't think it's a gopher, man.
It says it's a cute gopher, Kevin.
I'm sure that's like not a gopher at all.
So.
Did I spell it wrong?
Here.
Maybe I'm wrong about what a gopher looks like.
creating the file?
It should
Is that right?
Maybe I caught a roll, I don't know.
Maybe.
Right.
See here.
Yeah, I think that that's a gopher. You're right, I'm sorry.
No, you're
It's
good.
been like 10 years.
Results out text.
Well, there are many different species of moles that look very
Yeah,
different, so
yeah.
it's kind of hard to tell just from the pictures.
Let's just say it was a hamster that you caught.
Moles can be like kind of cute, anywhere from kind of cute to really fucking
Go through
weird.
ads. And in your messages, it's.
I'll go gopher.
So sorry, I didn't mean to leg you. Including this pound. When you fix it, tell me what you did. Mine has a -1. Dude, what did I do wrong?
Eventually it's just gonna go like this.
You need to change your CN.
This takes
to
you to
a-
so you
Your CN needs to go in the file.
Oh, I'm retarded, I forgot. Right here? Like in file. C in
That
file.
CN needs to go in the file.
Like that?
No, the CN needs to be in.
C in file?
No, it's the.
I'm just kidding. I'm just
Yeah, if you specify add.
Oh, thanks, dude.
How about we try to do that and then we see if the file.
We should make it in a P3 player.
It's gonna take a little bit
C++.
to understand how to.
Then just keep on going.
Good, yeah.
You know what? I just realized what the problem with these tables are. Some of them are turned around backwards. I'm so retarded for not even realizing that.
I didn't even know that
That's
was
all that was
closed.
wrong. I was like, man, I need to adjust it something on these. Oh.
I didn't realize that they were.
Or maybe
No, they're the
not.
same way. They're the same way.
Well, that just mounts on there, so it mounts it on the wrong way.
Alrighty. So unfortunately, we can't find where Solomon's file is being created in some mystery depth. You know, if we could find that app, that executable that's being created, if you ran it from there, you would find the source. You would see the results.txt made in the same directory, but I don't know enough about Xcode to find that.
I'm gonna build the solution then.
Okay, so using loops to process files. When we're doing the string extraction operator, which is the arrow to the right, it returns true when a value is successfully read and false otherwise. So we could just do this. To read the entire file in, you could do while, and then you could give it your input file, you know, and this will return true as long as it keeps reading, but once it hits the end of the file, it'll stop. So let's write a program that'll find our own file and display it on screen. Kind of stupid, but we can do that. Where it says int main here, change the name of your main to main2. We're going to write a new main. And we're going to declare an input file. So ifstream infile, infile.open, and we're going to open whatever your file name is right here. Type it exactly. Console application 4.cpp is the name of mine, just because that's what I opened. Whatever your file name is. And now let's define a string variable. We need to make sure that that file is open, so if not in file, display our error message. Bail out with a return -1. And then let's have a while loop. While in file arrow s, display that line to screen. Cout s followed by an end of line marker. And then just tack on a return 0 at the end. And if we look at it, it's reading in every word as a separate token. Because we didn't call getLine, we're seeing every single word that's in our file being printed out separately. But that's okay. I mean, we're just kind of playing around at this point. But you should get pretty well now the syntax. ifstream followed by the file name, or the variable name. You open it. If you can't open it, you print an error message and stop processing. And then you have some kind of loop that's going to repeat. In our other case, we were checking to see if they entered a -1. In this one, we're just ripping through the entire file, storing each tokenized string that we hit into the S variable and then printing that out. Anybody getting bizarro syntax errors? And again, Solomon's not going to be able to do this part.
I have a caffeine in an hour and a half. I'm about to die.
Ruh-roh.
I'm good though. I'm sorry.
On an error, is there a way to get the link, please?
Oh, don't hit him with the baseball bat. You said, is there a way to hit the lights?
Good question.
instead of hitting him with
I
the
hadn't
baseball?
thought adequately, this display the program adequately to get the white space. What we should be doing is calling get line, getting line by line, white space. Which
Dude, I incidentally had a bottle of 200 milligram caffeine pills that I gave away last night to the other guy that pulled an all-nighter. Because he had to drive for another 30 minutes to get home. Probably it ended up being 45 to an hour now because it was. Say what? Okay. I'm going to give you a quarter though.
So once you're done with your files, you should call .close on it. However, we did not do that, and it happened to work. And the reason that it worked is because once our program was done, it called .close. But the author notes, don't wait for the operating system to close the files at the program end. There may be a limit on the number of open files, and there may be buffered output waiting to be written. So after we've read from our files, we should close them. So after my while loop, I'm going to do infile.close right there. And I should go and modify that main2 to be the same way. I should go down to the bottom and do infile.close and outfile.close above the return 0. So I'm going to do that real fast. I'm going to go down to the very bottom of my main2 and do infile.close and outfile.close. So letting the user specify a file name. You can do that. Sometimes you want to let the user type it in. Well, you just ask them. You prompt them for the file name. And then you pass in that string as an argument to the open member function. So here, instead of infile.open and then that horribly long file name, I can make the user type that in every time. That'd be satisfying. Here's what it would look like. You don't have to make it do that. You know, string file name. Cout, please enter file name to open. And then read in that file name into that string. And then do infile.open based on that. There we go. Kind of like that. That would do it. That would let them type in the file name. So if I run it and I type results.txt, it's going to display results.txt. If I run it and I type in the name of the CPP file, it would display that instead. Enter file name to open, results.txt, and there it goes. It prints all that stuff out. And again, it's tokenized. It's not reading it in line by line, but instead word by word, and it's stripping out all the white space. Alrighty. That's all that this has in here about file I/O, but obviously we're going to have some, you know, an assignment that reads and writes to a file.
Can I ask you to show us something?
Mm-hmm.
I want to parse 4 bits at a time into an integer, and then write it to that. Just bitwise only.
So what's your input going to be?
Just you could write like gibberty gook into the text document, or just any file. So I only want it to read it in binary. So like not an encoded text file. Just it doesn't care what format the file is.
So you want to display all the bytes in it, but you said 4 bits.
Yeah, like I don't care what it does with the bits, just how to handle files purely in binary, like bitwise operations.
Let's look that up.
Thank you. That's usually what I do, and then anyway.
Okay.
I usually have to say sorry.
So here where I did the my while loop, instead I'm just going to make this while true because I haven't planned yet on how I'm going to handle this. And then I'm going to use infile.get, which will read in a single character if that's what we want. So char ch is equal to infile.get. That should read in a single byte. And then I'm going to display that byte to output like that.
So will that include the entire file, like even the header and stuff?
Yeah.
Awesome.
Let me make sure it works. Okay, and it's looping forever now because I didn't provide it for a way to get out. If infile.get fails, it's going to return, I believe, a null. So we could check to see if ch is equal to null. And if ch is equal to null, we would need a break. And this actually ties in exactly with the PowerPoint slide we are on right now. You can break out of a loop with a break statement. I believe we've seen this before, but we're going to do it again. And there's another important keyword involving loops as well. So if ch is equal to null, or 0, then break, because we are at the end of the file. There's no more we can do with it. Okay, make it 0 if ch is equal to 0. No, that's not going to work either. Let me,
Then a capital no.
yeah. Okay, it returns EOF if the read fails. So let's see if we can use that EOF right there. 0 is a valid byte, so I really don't want to be checking against null. And there we go. I read it character by character, and if you want to do something with that data, you would cast it into a byte or whatever. So now that I want to manipulate that character, you know, byte B is equal to, and I want the byte value of that character. Now it's a number, except byte's not working. Thank you so much. What's it called? A short int?
I think it's UNE.
Okay, a char really is a byte.
Oh,
If you feel like defining one yourself, you can do that. Alrighty. Okay. So forget that. But if you wanted to cast that to an int and do some math from it or extract some bits from it, you know, and it with, you know, certain bit set, you could do that.
thank you.
So breaking out of a loop. You can use break to terminate execution of a loop. It says use sparingly, if at all. It makes code harder to understand and debug. I kind of agree, but my habit of using while true and then having your break be the only way out of it, I consider an exception to this. Because when you see while true, you know that there's going to be a break statement involved, or else it's an infinite loop. So the fact that you see while true means that you're going to be looking inside the code, find your break statement, and that's the exit point for it. If you break out of a loop, but you have nested loops, it terminates the inner loop only. So if I write code like this, you know, int x is equal to 0. While x is greater than, well, let's just do while true. We're going to do 2 nested loops. And then int y is equal to 0. And then while true. Okay. So in here I'm going to say y plus plus, if y is equal to 10, then break. And this is a really stupid program, but it's okay. And then down outside of that loop, it's going to say x plus plus, while x, or if x is equal to 10, then break. So now we have a nested loop. That means that this loop is going to repeat over and over and over until it's broken, until it exits, and then it's going to do another iteration of the outer loop. So we go into here, x is set to 0. While true, well, y is set to 0. And then as long as we are stuck in here, we keep adding 1 to y. But eventually y will equal to 10. When that happens, we will break and we will come down here, because break only gets us out of the innermost loop. We add 1 to x, so we check to see if x is equal to 10. No, it's equal to 1 now because we started at 0. So we repeat our loop. Y is equal to 0 again, and it keeps iterating until y is equal to 10. It breaks out of that inner loop. It adds another 1 to x. X now equals 2. Is that equal to 10? Nope. So it repeats. The inner loop counts from 0 to 10 again, and then the outer loop increments. Okay, x is now equal to 3. And it's going to keep repeating this until x finally does equal 10. And when that's true, it's going to break out of here. Now, that's not good programming. These loops could be much more easily written using for loops. If I wanted to do something like this with for loops, it would just be 2 lines of code. For int x is equal to 0, x is less than 10, or x not equal to 10, x plus plus, for int y is equal to 0, y not equal to 10, y plus plus. Now what's absurd about this is that we're not even doing anything. You know, we're not printing anything or performing any calculations. So we could probably do our calculation right here if we wanted to. You know, we could print out x times y like that. Here, we could print out x times y inside our nested loop. There we go. Obviously, this is much more structured, easier to read, but I do want you to understand how the break statement works. And I know you've seen, we've used these before. If entering a series of values, if x is equal to -1, then break. So I know you've seen those before. All the break statement does is it exits the loop that it's in. It exits the innermost loop that it's currently in. So this break statement would break out of this while loop. This break statement would bail out of this while loop, which exit processing completely, because that's the outermost while loop. You can use a break statement in the middle of a for loop for some reason. If you hit an error condition and it's completely incapable of handling it, you could bail out of that for loop no matter what your counter was at with a break statement. Again, that's kind of bad programming, just as it notes. It makes it harder to read, because if you have more than one way out of a loop, then it's difficult to figure out when it's going to go that way. The continue statement. The continue statement is the opposite of a break statement. Instead of bailing out of the loop, it triggers an immediate repeat of the loop. Allow me to demonstrate. So up here, I'm going to do int x is equal to 0, and then while x is less than or equal to 10, do something. What's this something going to be? It's going to be x plus plus, and then I'm going to say if x is equal to 5, then continue. Otherwise, I want you to print out that x value. So what's it going to do? Well, x is 0. The very first thing it does is it changes it to 1. Is x equal to 5? No. So it prints it out. Repeats the loop. X is not equal to 2. Is it equal to 5? Nope. So execute the else. Prints out 2. Equals 3. Skips the continue. Prints out 3. It's 4. Still not equal to 5. Now it's equal to 5. Continue stops it from doing this. No matter how much code was in the loop past that continue statement, it zips back up here and repeats. I'm going to reword this just a little bit, and then I'm going to stick a return statement underneath it. Okay. So what this would do is it would print 1, 2, 3, 4. It's going to skip the number 5 because it never got to that line, and then it's going to print 6, 7, 8, 9. There we go. 1, 2, 3, 4, 6, 7, 8, 9. Now, that's a silly usage of it, but it demonstrates what the continue keyword does. Is when it hits continue, it immediately jumps back up to the top of the loop and reevaluates it. Is this condition still true? It's just like it hit the bottom of the code. So it's the opposite of a break. What's a break statement do? It goes to the the end brace, continue, rewinds it, and goes back to the beginning of the brace, or actually right here, so that it'll check the condition again. Used sparingly, like break, it can make the program logic hard to follow. All right, that is the end of Chapter 5. We've learned about continue, we've learned about break, we've learned about ifstream and ofstream. I want to hit Chapter 6 now, and then we will actually figure out what our assignment over ifstreams and ofstreams is going to be on Wednesday, but I have to do enough research to help Solomon find his files. I shouldn't just say Solomon. He's not the only person using Xcode. He's just the only person who attended class today who's using Xcode. Okay. If the next one is not about arrays, it needs to be. We may jump chapters in order to hit arrays. Functions. Seems like we've already talked about functions. think we're just going to eyeball this and then call it a day pretty much. But let's go in here and look. Modular programming. Modular programming is breaking a program up into smaller manageable functions. What is a function? It's a block of code, or he calls it a collection of statements to perform a task. Your motivation for modular programming: to improve maintainability of programs, to simplify the process of writing programs. So if you're writing a video game, you may want to make your draw code, in a function so that you can call it, that function, every time you want to redraw the screen, rather than just have all that draw code right there inside of main. Here's our example of it. This program is one long complex thing, and it's got 20 statements in it. You could try to break it up so that you have a function here that has some functions in it. You have a function here that has this functions in it, and you have another function here that has these functions in it, and then main would call these functions. So this code's not actually written right. It should say function 2, function 3, function 4 right there. And so when you ran main, the first thing it would do is it would execute the 3 statements inside of function 2, if that said function 2. Then that next line should say function 3, so it'll run down here and run those 3 lines. And then it should say function 4, so it'll run down there and run those 3 lines. So it's just like doing chapters of a book. It's breaking it down into little bitty steps. Defining and calling functions. We know how to define functions. We have done that so far. What's the difference between a function call and a function definition? The function definition is where you write the function. It's all the code that goes into the function, where the function call is where you invoke it. It's the actual line of code that calls the function, that causes it to run. When you define a function, it has to have a return type. It has to have a name. It has to have a parameter list, although the parameter list might be empty, and then it has to have a body. So the last thing we're going to do is I'm going to go back into my Visual Studio Code here and define a function that all it says is hello. The most primitive function of all. But it has to have a type. It's going to have a data type, or if it doesn't return anything, it's going to have a type void. Then we have to give it a name. I'm going to call it hello. Then it has to have a parameter list. Maybe I'm going to pass in a string, that's the name. Okay, so what hello is going to do is it's going to display the words hello, comma, followed by the name, followed by an end-of-line character. And I'm using the wrong arrows again. I'm using string extraction rather than string insertion. There we go. So then inside of main, every time I want to say hello, I can just do that. Hello. This actually is not going to work. I'm not going to be able to do it that easily. I don't think it will convert that to a string on the fly. What do you know? It did. Okay. So if I want to say hello, Fred, it's as easy as doing this. Hello, Fred. And then later on, if I want to say hello to Barney, I can repeat the call to hello. Hello, Barney. Then later on, inside of our while loop, if I feel like saying hello to Dino, there we go. All right. So I can invoke this. This hello function could be 1,000 lines of code long. And running it is as easy as putting the word there, followed by the parentheses, followed by any arguments that it requires. The number of arguments has to match the number of parameters that are defined here. This parameter is a variable called name, which accepts the data type string. So here I have to pass in something that is a string. Now this is actually an array of characters, but the string will accept an array of characters as a string. We haven't talked about arrays much yet. We certainly have not talked about string arrays yet, or character arrays, which we will. All right, now this is pointless for me to actually run this, but if I run it, it should print, hello Fred, hello Barney, hello Dino, and it's going to print out a whole bunch of hello Dinos because that was inside a while loop. Alrighty, gang, let's call it done. We did some work. Let's create a Dropbox for it. Let's upload our file that read from input and wrote to output.txt. So this one's in class K. If it didn't work for you, that's okay. Go ahead and upload this anyways. Hopefully, if it didn't work for you, though, you raised your hand and asked me for help. If you didn't do that, then we can hang out afterwards and get it working. So if you refresh your Dropbox, you'll see in-class assignment K. And it should have today's date on it now, if you refresh it again. Ooh, who was the first to upload? I have to look. Alexander and Sean beat everybody else to the punch. Alrighty, gang. So like I said, even if you didn't get it working, upload something. On days that I don't take attendance, I take it based on what got uploaded to the Dropbox, so you want to make sure you got something in there.